Hello class, welcome to segment 6 in our online adventure in chapter 4, ratio and regression estimation. Last time we did a couple of examples where we actually worked through the mechanics of ratio estimation. This time I'm going to show you how to replicate those in R, and then we will move on to additional segments to deal with other examples. So we've already looked at this in the previous example. So we were looking at estimating the average education among those who in our Falcon Villas population voted in the last election. So in order to cast this in R, we need to create the D variables and the U variables that we'll use in the ratio estimation itself. And so again, we're taking the example data set, which was a sample of size 10 taken without replacement from our sample villas data set or population. And I'm just creating a D variable here. You can actually name it whatever you want, but the idea is that this is the indicator function that is going to tell me whether or not a sampled unit is in the domain or not. We mentioned last time when we were working through these examples that this domain indicator was exactly the same as the voted 2000 variable. So I'm really just assigning the voted 2000 variable to this D variable. I also need to create the U variable, which multiplies the individual D variable by the outcome that we're looking for. The outcome variable was education, and then the D variable we just created. Multiply these two together in a vector form. I'm going to get the U vector. Then I need to calculate the FPC for my simple random sample. And so we know the population size is 24. And so I'm going to do this exactly as we've done it in chapter 2. Now the survey design object is very familiar to you. This is a simple random sample without replacement. So we use the survey design function of the survey package in R. Everyone has their an ID equal to 1 because everybody counts for themselves. And the data was the example 49 data. Now it's important to note that this data set will include the U variable and the D variable because we will reference that later in our estimation process. The FPC again is the population size, as we've already indicated. Now I'm going to apply a survey ratio estimator to generate the domain estimate along with the standard error. And essentially I'm going to use the survey ratio command. Now here I'm not going to use a predict function with a survey ratio object because in the domain estimation, the actual estimate that I want is the B hat, which I will get from using the survey ratio command. So I will specify the numerator variable first, which is the U variable that I created earlier. I'll specify the denominator variable, which is the D indicator variable. And then of course the design is the sample design object that I created earlier. Once I specify this code, it will give me two items, the ratio. Again, this is the numerator, this is the denominator of the ratio, and it looks like the average years of education for those who voted in the 2000 election is about 16 1/3, which is exactly what we computed by hand. The standard error for the ratio is a little under 1 1/4, which is exactly what we got when we computed this by hand. Now there is an alternative way. So this way forced us to specify the U variable and the D variable. And this is actually just working through the mechanics of what we've already specified before in the prior examples. But there is a faster way in R to do this as well by using the by variable, which does not need to be a factor variable in the data set. But be careful if it isn't, because you might have more levels than you need in the output. And so in this case, we'll use the SVY-BY function in the survey package in R. This is shorthand notation for survey by, or you want to make estimates of a variable by certain groups. Those groups, of course, are the domains of interest. So in this situation, my domain variable is very easily obtained with the voted 2000. I don't need to create another variable there. If, like in the prior example that we talked about, where we needed 4 variables, like the age, whether you were a female, whether or not you had breast cancer, and whether or not you had, say, health insurance, if you require multiple variables to create the domains, You can use multiple bivariables here by crossing them, or you can actually just create the variable outside of this and then refer to that variable in the data set as I would refer any variable by putting the tilde beforehand. So in this case, what I want, the way I would read this command is I want to create estimates of the education variable. So this is my outcome variable that I care about by this domain variable according to this design object, and the function I want, the estimate that I want is the mean. I don't want a total, I want a mean. So in this case, you need to specify the function. It's going to be survey total, survey mean, etc. The by variable, which is clearly tied to the domain of interest, and then the outcome variable that you want, and then of course the design object. The output is going to be here. You're going to get one row per every level of the domain. Now in my case, or in our case, we only cared about those who voted in the 2000 election. So you're going to get multiple rows. This is very similar to what happens when you're trying to get survey proportions by a classification variable that has 5 levels and you really only care about one level. You're going to get multiple levels in the output, but you can just focus in on the level that you want. So here you see that the average education for those who voted in the 2000 election in Falcon Villas is estimated to be 16 1/3. The standard error is just under 1 1/4, which matches what we've already done by hand and also by using the ratio functions in R. So this is, if I wanted to look at the other information for the total income, the other portion of the example, then what you'll see here is me creating the D variable, so whether you voted in the 2000 election, and then creating the U variable, which is the income multiplied by the D variable. That gives me my overall U variable for that second part of our example. Survey design object is specified exactly as it was before. The Y bar U is here, is the survey ratio object, again with the U variable being defined as the income multiplied by the indicator of whether or not I voted in the 2000 election, and then so on. So my T hat U, though, is assuming that the number in my domain is 13, is gotten by this predict function. I'll take the Y bar U object from the ratio, so that's going to be my B hat, and I'm going to multiply that number by the total equals 13 because I'm assuming that I know it. If I don't know the N sub D, then I'm going to use N equals 24, and I'm going to do exactly the same thing there. Or I can actually specify the survey by function here and the survey total object here. Now it gets, the survey total automatically incorporates the N equals 24 because most of the survey total packages use a function N, capital N, Y bar. That's the standard way that survey totals work. And the capital N is obtained from the survey design object. So I don't need to specify a separate predict statement, although I could do that separately if I wanted to specify it in exactly the same way using the survey ratio function. I could do the same. But again, this gives me the total for the first, so this last part here is going to give me an estimated total of 539,100,000, and then the standard error would be 33,397. And again, we mentioned that this is about 4 times the standard error that you should be getting up here because of the fact that I don't know the subdomain total. And again, if I don't assume, sorry, this part here is the estimate that I got from this series of the predict function. And then on the following screen, this is what I get if I don't know the N sub D. And again, the standard error is about 4 times the amount. And here's my estimated total. Now, if I use the survey by command here, you'll also see that I get the same thing for the domain object of 1. This is the 597, and then the standard error is about 129,000. So if we look at another example here, can Democratic residents of Falcon Villa rant more than Republican or Independent residents, where ranting is measured by the total words that can be typed by these residents combined? So we're trying to estimate a total. We want to use the sample that we drew from the previous exercises. We want to estimate the total number of words that Democratic residents of Falcon Villa can type within a minute, as well as the standard error and a 90% confidence interval. Here is our multiplier, our critical value based on a sample of size 10 with 9 degrees of freedom. And we'll assume that we don't know the number of Democrats in our population first. Then we'll repeat this exercise assuming that we do know the number of Democrats. So here's how we can actually do this in R. So first, we're going to create an indicator for whether or not you're a Democrat. Now, the political party variable had 3 levels, so I need to just create a binary indicator for whether or not you're a Democrat. That's exactly what I did here using this if-else command here. So basically, if this function is true, I'm going to give you a 1. If it's not true, then I'm going to give you a 0. And then I'm going to create the u variable by multiplying this indicator by the total number of words variable. I'm going to specify the survey design object that we've done before. Then I'm going to actually carry this out by using the survey by. I want an estimate of the total words. The indicator is, the subdomain of interest is indicated by this d variable. My design object is what we've specified. And the function is survey total because I want survey totals here, not means. So if I assume that I have no domain estimate for the population size of the domain or the number of Democrats in my population, I can use survey total here, and then the tilde u, and then the design, etc. Now remember, this is the no ND, so I'm going to use the capital N times U bar as my estimate. So the capital N is already implicitly specified here because of the survey design object. This is what I get for the total. This is what I get for the standard error. Here's my confidence interval for the no ND option. And again, I'm going to use the deg-free function to just pull out the 9 degrees of freedom. And that's going to give me the critical value that I mentioned earlier. Now, if I know that I know the n sub d, I'm going to predict the survey ratio. So I need to get an estimate of the b hat. So this is something we've already done before. And then I'm going to specify what the total is so that I can multiply the overall b hat times the total. And in this case, my total is about 228,989, and the standard error is about 4 times less, or 3.5 times less what I got by the situation where I did not know the number of Democrats in the population. Here again, I'm going to apply the confidence interval. I'm going to use the survey ratio object here. I didn't make a separate object for it, so I'm just incorporating that in. This is actually the b hat. The level is 90%, of course, and then the degrees of freedom is going to be obtained by this function applied to the survey design, which is effectively 9. And then I'm going to multiply this out, and you're going to see this is my confidence level here. So again, and this is an 8, should not be there. That's a actual typo. Let me fix that while we're here. Sorry about that. So you will see here that that gives us back what we need. Now you can see obviously that the confidence interval for this is a bit tighter than it is for this one, in part because the standard error is so much smaller, but it looks like that the neighborhood of the overlap here is somewhere between 25,000 and 33,000 words that Democrats can type, relatively speaking, in the population. That would be our estimate, somewhere along those lines, with 90% confidence. This ends the segment on going through these exercises in R for domain estimation. Keep in mind that you can also get the output of the survey by function here, and keeping in mind that that's going to give you the totals for each of the subdomain elements, but it's going to assume that you do not know n sub d. So in any case, if you want to do this knowing n sub d, you're needing to use this predict function where you can actually override the default total, which is the capital N estimate from the survey design itself. Okay, so in the next segment, we're going to be talking about regression estimation, and we'll be closing out this chapter talking about regression estimation, which generalizes ratio estimation and doesn't force regression through the origin. So until then, I hope you all are well, and thanks for watching.